Hello, this is Mr. Henry, and welcome to lesson 4.10. Constant rates again. So the essential question says, how do I use constant rates in different forms to determine if one rate is greater than another? And we have a type 1 for our warm-up here. It says, write for 2 minutes on what you remember about constant rates. So just give some thoughts, give some details about what you remember about constant rates. When you're ready to continue, let's move on to the vocabulary, hit play, and we'll move on. All right, so obviously we're going to use the word constant rate quite a bit throughout this lesson. So I don't have the vocabulary up here because we already talked about it in the past. If you need to look it up, look it up. But average speed will be a new word that we'll talk about a little bit throughout the video here. So average speed is something divided by time. I mean, so distance. If you're driving a car and you go 300 miles in 2 hours, well, if you would divide that, you'd get 150 miles in 1 hour. Maybe that's not a car. Maybe it's a jet or something. That would be your average speed. Or if you're work done, if you're writing a paper, you can type 10 pages in, I don't know, use 2 hours again, 5 hours, whatever. 10 pages in 5 hours. If you would divide that, you get 2 pages in 1 hour. That is your average speed of doing your work. I mean, maybe 1 hour you wrote 3 pages, 1 hour you wrote 1 page, but on average, if you did 10 pages in 5 hours, your average was 2 pages an hour. Or even something stupid like hot dogs eaten over time. That would give you the average speed you ate hot dogs. Okay, so this will be the slope of the line when it's graphed. So if I was going to graph this chart of the distance traveled over time of this jet, I guess, so it's going pretty fast here, this average speed would be the slope. This guy has a slope of 150 over 1. You'd go up 150 miles over 1 hour. If we're talking about work done, the slope here would be the slope of 2 pages in 1 hour. Hot dogs eaten, whatever it is. If it's 50 hot dogs in, I don't know, whatever, 10 minutes, then the slope would be 5 over, what did I say, 50 hot dogs in 10 minutes? 5 over 1, 5 hot dogs a minute. Okay, that would be the graph. That would be the slope of the line. Have a slope of 5 over 1. Okay, so let's get to it. So the first problem says, Nancy uses gourds to make birdhouses. She makes her birdhouses at a constant rate, which means it's proportional, and the table below shows the number of birdhouses she can make with respect to time. Represent this relationship as an equation and as a graph. Okay, so it gives us a table. Yay, isn't it pretty? We want to take this table and represent it as a graph and as an equation. Now, all three of these are just different ways of representing the same exact information. It's all a constant rate of how fast Nancy is making these birdhouses. So the graph we can use just by plugging in points. So we need a scale first. The x-axis is only going up to 3. The y-axis is going up to 9. So I'm going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And up to 3. I mean, I could do 1, 2, 3, but that leaves all this extra unused space. So how about 1, 2, 3? That's better for me. And then we graph. So we got 0, 0, 1, 3, 2, 6, 3, 9. So the graph is that. That's the graph of the relationship shown by this table. So table, graph. same thing. The equation will also be the same. The equation is going to be, well, we've seen it a few times, it's this relationship. So if I say time and houses, those are the two things that are being measured. In 1 hour, she makes 3 birdhouses. In X hours, she makes Y birdhouses. And the X is because the time is the X, the Y is because the houses are the Y. And if we cross multiply here, we get 1y equals 3x. And that's already solved for y because you don't need the 1 in front of the y. You divide by 1, you get the same thing. So we have an equation. We have a graph. We have a table that are all showing the same information. A couple things to point out here. One is this 3 is the slope of the line. Y equals mx plus b. Remember this from the last lesson, this slope-intercept form? The slope is how steep the line is. So from one point to the next, I would go up 3 over 1. So up 1, up 2, up 3 over 1. And it's 1 because this is 1 unit, is 2 boxes here. 1, 2, 3. So that is up 3 over 1. Up 3 over 1. Up 3 over 1. So the slope of the line is the relationship between the x and the y values, between the time and the houses. That is the rate at which she's working. She's working at 3 houses per hour. Every hour, she goes 3 more houses. 1 more hour, 3 more houses. 1 more hour, 3 more houses. Okay? So, letter B says, Sean rides his bike at a constant rate. The equation y equals 8x, where x is the time in hours and y is the time in the miles traveled, represents Sean's rate when on his bike. Nicole also rides her bike at a constant rate. The rate Nicole rides her bike can be seen in the graph below. Who rides their bike faster? So this is Nicole's rate, and Sean's rate was y equals 8x. And we want to know which of these is greater. Now, anytime you're comparing two things, you always want them to look the same. If you're comparing two fractions, you have to have the same denominator. If you're comparing, any numbers, you want them to have the same form so that you have an equal comparison. So I either need to take this graph and write it as an equation, which we just learned how to do in the last lesson, or I need to take this equation and graph it, which we learned how to do in previous lessons as well. So either way works, or I could do both ways and just verify my answers. So I'm actually going to do that in this problem. I'm going to do both ways just for the sake of argument and just make sure we're complete and clear in our understanding of what's going on here. So I'm going to take this graph and I'm going to write it as an equation. So the equation, I need to have a slope and I need to have a point. I'm going to use the point 0, 0 because it's easy. And the slope, let's see, I go up 10 over 1. Maybe it's not quite 10 because this is not up 10 more. So this is not quite 10. The only point it looks like I know, this one looks like it's exactly, 45 and 5. So I'm going to say 45 over 5, which is 9 over 1. So that's why this is not quite 10, because that's going up 9. And 9 more is 18, and 9 more is 27, and 9 more is 36, and 45. Okay, so the slope is 9, and the point is 0, 0. So now we can write the equation. Y minus y1 equals mx x minus x1. Y minus 0 equals 9x minus 0. This cancels out. This cancels out. So Nicole's equation, this is Nicole. Nicole's equation is y equals 9x. Sean's equation is y equals 8x. So now that we have them in the same form, who rides their bike faster? The answer is Nicole. Nicole would ride her bike faster because she's biking at a faster rate. Every hour, I go put a 1 here, Nicole goes 9 miles. If I put a 1 here, Sean goes 8 miles. So Nicole rides her bike faster than Sean. Okay? So now we've changed Nicole's graph into an equation. What about Sean's equation into a graph? Well, I can do that. I can make an XY table. X, Y, ba-dum, ba-dum. I know if I plug in a 0 for X, I get a 0 for Y. And I just come up with a couple of values, just enough so I could put some points and make a line. So what if Sean bikes for 2 hours? If I put a 2 in here, 8 times 2 is 16. Okay. If Sean bikes for, I don't know, 5 hours, whatever. 5 times 8 is 40. Okay. I've got space for one more, so let's get one more. How about if Sean bikes for 3, 4, 5, 6? Sure, I'll do 6 hours. In 6 hours, 6 times 8 would be 48. Okay, so Sean's graph, there's a blue dot there. 2, 16, that's 15. So 16 would be a little above. 5, 40, that's much lower. 6, 48. Like that. So if I connect the two, let's see, I'm going to use a black line for Nicole. And I'm going to use a blue line for Sean. You can see that Nicole's line is steeper. The unit rate is higher. The slope is bigger. The rate of change is greater. So Nicole rides her bike at a faster pace than Sean. In the same amount of time, which is this unit, this is time, Nicole gets more distance. Letter B. Matt, Joelle, and Angela are each painting a room in their houses. The rate that each of them works is constant and can be represented by the table, equation, and graph below respectively. Order the 3 painters by their painting speed from slowest to fastest. Okay, so we want to figure out who's the slowest painter and the next slowest and the fastest. And I have Matt's and Joel, and Angela is on this page. So I'm going to go through each of them, and I'm going to write them all in the same form. I think probably the easiest way to compare them is by the equation. Because the equation gives you a definite who's faster and who's slower. So if you look at this, oopsie, wrong one. If you look at this, Sean was 8x, Nicole was y equals 9x. 9 is bigger than 8, so Nicole's rate was faster than Sean's. So I'm going to change each of them into an equation. So Joel's here is already done. Y equals 100x. That is his equation. Okay, so if I can change Matt's rate into an equation and Angela's rate into an equation, I'll be done. Or then I'll be able to figure out whose is faster. So Matt's, let's see. Well, this is our x, and this is our y. I'm going to use that proportion because this is a proportional relationship because it's constant. So if I say time and painted gives me I'll pick a value that's not the zeros, because the zeros don't help me out here. So 1 unit of time is 150 painted x, y. Cross multiply 1y equals 150x. And if I divide by 1, I'm going to get the same thing. Y equals 150x. Okay, so Matt paints faster than Joel. Matt paints at 150, what's it, square feet an hour? Feet squared? Doesn't say what the units are. Yeah, square feet. So Matt paints at 150 square feet an hour. So if Matt painted for 1 hour, he painted 150 square feet. If Joel painted for 1 hour, he painted 100 square feet. Okay? So Matt is faster than Joel. Let's see where Angela falls. So we're going to turn Angela's graph into our equation again. So let's see. Matt was y equals 150x. Joel is y equals 100x. And Angela. So to turn this into an equation, we need slope and a point. Slope and point. Point I'm going to use, again, is going to be 0, 0, because that's the easiest point to plug in, and we know it works. Now, these other points, I cannot tell you exactly what that is. That looks pretty doggone right there. So that might be 4250. 4250. Let's check. That looks like 8500. So those 2 points look like, yeah, that's on a line. Okay, so I'm going to use the smaller one. Or I got to find the slope. That's what I'm finding here. So from one point to the next, so if I go from these 2 points, if I go up, how much? How much is it from here to here? That's at 250 to 500. So that's going up 250 over 1, 2, 3, 4. 250 over 4. And what does that simplify to? Clear. 250 divided by 4 is 62.5 is my slope. Okay, so I have the slope, the rate that Angela paints at. So now we're going to write it into our equation. And if you heard me right a second ago, the slope is the rate of change. The slope is the rate that Angela paints. That's going to be her number. So like Matt paints at 150 square feet an hour. Joel paints at 100 square feet an hour. Angela's going to paint at 62.5 square feet an hour. But let's do the math. Y minus y1 equals m. X minus x1. Y minus the point equals the slope. X minus the point. This cancels. This cancels. Y equals 62.5x. So this is Angela's rate of painting. So the question was, order the 3 painters by their painting speed from slowest to fastest. So the slowest at 62.5 feet per hour. Next is Joel at 100 feet per hour. Fastest is Matt at 150 feet per hour. That slope is a unit rate. It's how far or how much they paint per hour. So in 1 hour, Angela paints 62.5 feet. In 1 hour, Joel paints 100 square feet. In 1 hour, Matt paints 150 square feet. So that is the order from slowest to fastest of their painting speeds. Okay, last problem. It says, during the 2014 Nathan's Hot Dog Eating Contest, Matt ate his hot dogs with a constant rate and is shown in the table below. The rate which Joey ate his hot dogs can be seen in the graph below. Who won the contest, Matt or Joey? Okay, so that's question number 1. Who won the contest? The time to eat hot dogs in the contest is 10 minutes. How many more, which is a difference, which means we're going to have to subtract, how many more hot dogs did the winner eat than the second place competitor? Okay, so here's the information you need that you did not have on your note sheet. So if you could please pause the video right now, do this problem on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so to figure out who won the contest, obviously whoever ate the hot dogs faster won, right? I mean, if you're in a race and you're the fastest person, you won the race. So that's what we're going for. So we're going to look for who had the fastest time, who had the greatest rate of eating hot dogs. I'm still going to make equations. I like the equations. So this is what? Matt, right? Yes. Matt, let's see. Well, the time over hot dog, X, Y. So in 1 hour, minute, he ate 5.6 hot dogs. So in X minutes, he'll eat Y hot dogs. We cross multiply. 1y equals 5.6x. We don't need the 1 out front, so that gives us, this is Matt's rate. Every unit of time, he ate 5.6 hot dogs. So in 1 minute, 5.6. In 2 minutes, well, there it is, 11.2, which is another 5.6. So every minute, he ate 5.6 hot dogs. Okay. Now we got to figure out Mr. Joey's time. So this is essentially just the slope of the line. So if we can find the slope of the line here, that would be the rate. Okay, so let's see. Is this going at a constant? Well, it looks, 1, 6, 2, 12, 3, 18, 4, 12. Yeah, so that is every 6 up, go 1 over. Up 6 over 1. Notice I'm not counting boxes, I'm looking at the units. So from here to here is up 6 units this way, and here to here is over 1 unit that way. So the slope is 6 over 1. That would be his rate. So y equals 6x. Every 1 unit of time, he ate 6 hot dogs. If you plug in 1 times 6, y would equal 6. So when the x value is 1, the y value is 6. If I plug in some other number here, if we plug in, say, x equals 3, 3 times 6 is 18. So in 3 minutes, he ate, look at that, 18 hot dogs. So that is Joey's rate. So Matt ate the hot dogs at 5.6 hot dogs per minute. Joey ate his hot dogs at 6 hot dogs per minute. So who do you think won the contest? Answer is Joey. Joey won the contest because he ate his hot dogs faster. He was the fastest hot dog eater that day. So, question number 1. Who won the contest, Matt or Joey? Ooh. Joey won the contest. Answer number 1. Okay, question number 2. It says the time to eat hot dogs in the contest is 10 minutes. How many more hot dogs did the winner eat than the second place? So how many more, as I said up here, little hint, it's subtraction. So we want to find the winner subtract the second place guy, that'll tell us this difference. How many more? So how many hot dogs did the winner eat in 10 minutes? Well, we already said that this is a unit rate, meaning that all we have to do is plug in 10 for the number of minutes, and this is going to spit out an answer. Y equals 60. So in 10 minutes, Joey ate 60 hot dogs. Okay, what about Matt? Matt's rate, y equals 5.6x. So in 10 minutes equals y, Matt ate 56 hot dogs. And if you subtract them, the difference is 4. So there was a 4 hot dog difference between the winner and the second place. So let's write that down. So make sure we answer the question. How many more hot dogs did the winner eat than the second place competitor? The winner ate 4 more hot dogs than the second place competitor. ITOR. There we go. Answer number 1. Answer number 2. Okay, so for our vocabulary, if I type 1 here, 2 minutes on the clock, it says, what is the relationship between rate and the slope of an equation or a graph? That slope. What's the equation? What's the relationship between rate and slope? Go ahead, pause the video, answer the question in your Collins writing page. When you are done, well, this has been lesson 4.10. Thanks for watching.